again, welcome back. Just bear with me for a moment. Thank you, that's better. Right, we will look at Kirchhoffs Laws. So what I want to do is continue with Kirchhoffs Laws Part 6. Okay? Now please note that you need to write out all the information given in the videos to make it your own. That is important. Okay? You will not learn it simply by looking at it from the screen. It does not work like that. Okay, so let's carry on a little bit here. Now all I'm doing, I'm moving up a little bit, and I've given a question here. A circuit having an EMF source of 4 volts with an internal resistance of 1 ohm. This network is connected in parallel with another source of EMF whose value is 6 volts. Now I don't want to spend time reading this out to you. You need to be able to read this for yourselves, okay? And I have no doubt that you will be able to, and that you can. But again, let's try and make sure that you understand what's been given. Now again, it's important to write out the information, draw the diagrams. Now I've just gone a little bit here, okay? Now be aware here, it says calculate A, the current in the 4 volt battery, B, the current in the 6 volt battery, and C, calculate the current in the 15 ohms resistor. So what I've done here first is to give you a diagram that you need to draw out first, okay? So be aware of that. You need to draw a diagram out in full. Let's just go in a little bit, make sure you can get everything, okay? And I'll pan out a bit more, okay? Draw out the diagrams. Then don't forget to put in your you can put in references of A, B, C, D, etc. if you choose to, or if you feel that is appropriate for you to do, and it will aid your understanding. So be aware of that. Do that for yourselves. But that I'm going to leave as a matter of choice. Okay? Now here, the resistor 15 ohms and 10 ohms are connected in parallel. Now apply the rules for resistors in parallel in order to come to a total value, and you'll see what I've done as I move on further. Okay? This is not a quick step. There is no shortcuts to this. You need to write out the information given in order to help you to understand it. Now here I've used the RT equals R1 times R2 over R1 plus R2 rule. Okay? And when you apply that, it will give you now the value of 6 ohms. Now remember, that rule only applies to 2 resistors. It does not apply to the whole circuit. It will not work. Okay? Yes, I know there's a rule also for 3 resistors, etc., but that can be done for another time. But let's deal with this as it is now, making sure we understand the concept that we have applied. Now again, this is for you to read out. We now have the total resistance of the 15 and 10 ohm resistors. We now have to put that into the circuit, so we draw a new circuit diagram. Now here is a new circuit diagram. Draw it out. Do not make excuses for not doing the work. Okay? Draw it out. Make sure you are familiar with it, that you know why and where that 6 ohms resistor came from. Okay? Now I've given here Continue with diagram ZA1, okay? And here I've given you the equations in each stage. Now, do some reading up on Kirchhoffs so you understand these equations, okay? Because I don't really want to be trying to explain to you if you're familiar with it already. But mainly the explanation is for those people who have a certain dispensation with figures or equations. It's to enable them to understand it and to come to grips with it more easily. Some of you, I know, are geniuses, okay? But I can tell you this, I remember quite well sitting in the class when I was doing Kirchhoffs, and it went right over my head. It is only when I sat down to begin to read it and dissect it that it began to make sense to me, okay? And yes, I do hold an HNC in electronics, and I do hold an ONC in electronics as well. And I did do my BH degree at UCE, but then events were changing, so I decided to go into IT. Okay, but again, keep this information in mind and look at what I did and what I've said that you need to do in order to understand how we've arrived at these equations. Now here you'll see I've put a -4, okay, and if we've taken equation 7 from 8, which will give you a -4, but that -4 cancels out further on down the equation, okay, and you will be able to see that for yourselves. So I began to ignore it. Now that I2 should equal minus 0.2 amps, which I believe it does. But because it works itself out, I've left it as it is. But please check for yourself. Make sure that you're happy with the result. Okay. Now I know the results here again has come out correctly, because as I will show you in a moment, it equates. Okay, and I'm just panning out a bit here for you to get all this in for yourselves. Okay, now here I've gone down further, and I know it works because each side has balanced. Okay, and it has balanced quite well. And as I said before, trying to remember that. Again, remember that I'm looking at it from a perspective. Okay, apply the sine and minus sign rules, which you will find in maths, and some of you are quite good at that yourselves. So you should be able to see what I'm trying to say here. Okay. We now have to find the voltage drop across the 15 and 16 ohms, 15 and 10 ohms resistor, sorry, 15 and 10 ohms resistor, okay, that were in parallel. So remembering that I1, the total current flowing is I1 plus I2, and because I know it has worked out correctly earlier, it should now be 0.8 amps. So voltage V equals I times R, 4.8 volts across that parallel circuit. Now remember, it's the voltage across that parallel circuit. Now again, bear in mind, I may be wrong. I might have miscalculated something here. I may have overlooked something, but please work this out for yourselves. Do not take it as read. Do the calculations for yourself. Make sure you understand that concept. So what I've then done here is going on further. Having the voltage and also having the resistance, I can now find the current across that circuit. So I equals 0.32 amps. And when you add that up, you'll find it is the same current flowing in the circuit in regards to the 15 ohms and the 10 ohms resistance that were in parallel. Okay? Now take your time and write this out slowly. Look back at some of your Kirchhoffs Laws. Do a little bit of reading for yourselves. Do not take my word as read, because I can make errors, and sometimes I may look at things differently to how you will see it. So look back, do a bit of reading, get the information that you need. If I'm incorrect in any way, please do let me know. I'm happy to accept comments, because one thing, I'm definitely not perfect. I may be handsome and good looking, debonair, but not perfect. Okay? Right. I hope that you'll find this useful and helpful. I'm just going to scan back a little bit wider. Okay? And that will be us for today. Okay? So let me just bring it to a close completely. Okay? Down to the blank page. And please do excuse the blank page, but it tells me that I'm at the end. Thank you for your